For the Tiger Neo 2, it used to be 80%, today is 85%. And we optimized the temperature coefficient, so the module will lose its power less in hot and humid temperatures. So it used to be minus 0.29%, today it's minus 0.26, and we will see the difference later. The annual degradation, we know that every year the module will lose some of its power over the 30 years of warranty. So this power loss is also reduced, optimized. It used to be minus 0.4%, today it's minus 0.35%. Also, the TopCon Tiger Neo 3 cell is expected to have better low light performance, meaning in conditions cloudy, such as today, or in startup in the morning and late in the evening, we are expected to have 2 to 3% better performance than the competitor cells. So overall, we expect 3 to 3.5% of improvement of gain per watt compared to the back contact technology that some of our competitors introduce. So one of the key improvements, let me just close this. One of the key improvements or updates that we did with the Tiger Neo 3 is that we moved to a 4-piece cut of the cell. So the Tiger Neo 2 used to be a half-cut module, meaning that we half-cut the cell into 2 pieces. Today we are cutting the cell into 4 pieces. And why we're doing that is to reduce the current within the cell, therefore reducing the thermal losses. Thermal losses are I squared times R. So we're reducing the I to better improve the efficiency of the module. And this has helped us gain 10 watts per unit. And then we have also, with this 4-piece technology, modified the circuit in the way we connect these cells together to have a better performance in terms of partial shading. So we will talk about the anti-shading behavior of the cell. So the Tiger Neo 2 half-cut module, we will find that both the first and the second column are connected in series, meaning that if partial shading is presented in the first column, automatically we will lose the second. With the Tiger Neo 3, only the affected area now will be out of production. The rest of the module will continue to produce normally. So for the first case, we will find 63% of the power. For the Tiger Neo 3, we will find 84%. So 20% improvement in terms of shading behavior. The bifacial factor, Tiger Neo 3 now presents the highest bifacial factor in the market, 85% plus or minus 5%. Compared to that, we will see the Tiger Neo 2 presenting 80% and the back contact technology only reaching 75%. Now, if you want to translate this percentage, like what does it mean and how we can translate it to actual power? 85% meaning that if we take the front face of the module and the rear face and we put them in the same condition, STC condition, 25 degrees ambient temperature and 1000 watt per meter square of irradiance, the rear side will give us 85% of the power that the front side gives. See how the analogy works? So now if we want to translate that to actual power on field, it will depend on many factors. One of them is the bifacial factor, but also the distance between the rows and the height of the module, the way we install them, the inclination angle, because this will allow to capture more or less of the reflected irradiance that hits the ground. So basically, the light will hit the ground and then hit the back of the module, and that will give us additional power. So when we talk about a module that is rated at 670, for example, anything we get from the rear side is additional. So that 670 is just for the front side, and the rest is additional power. Okay, so the additional power, for example, in the case of a normal installation, ground mount installation, sand, you will find 5.4 watt of additional power for each module. Okay. And since that we said that the Tiger Neo 2 presents the highest bifacial factor, meaning if we consider the overall efficiency, efficiency of the front side and the rear side working together, we will find that Tiger Neo 2 has the highest overall efficiency. And this concept now is introduced also on the technical data sheet of the module. The PNPI part, it's a new part that was added in 2021, where we can evaluate pretty much the performance of the module, front and rear side working together. Now we will compare both cell architecture, the TOPCon. We know that Tiger Neo is based on TOPCon architecture, and the back contact is based on a back contact architecture. Okay, the Tiger Neo, we will find that the metallic contacts that collect the current from the cell are respectively positive on the front and negative on the rear. For the back contact, we will find them alternating on the rear side of the module. We'll find plus, minus, plus, minus. So the distance between these contacts is reduced. We have the full cell and the TOPCon to go through, but for the back contact, the resistance and the distance is reduced. Therefore, creating a phenomenon that is especially observed in low light conditions, where it's called the leakage current. When the cell is put in low light condition, the current no longer passes through the normal circuit, and it will kind of shortcut between the metallic contacts. So, meaning that if we take two modules that are identical in power, one is TOPCon and one is back contact, we can find that on the data sheet, 1000 watt per meter squared, they are the same in terms of performance. But when we start in real life conditions, in cloudy conditions, or in the startup in the morning, we will find that we are in low light condition, not in the 1000 watt per meter squared. And when we start to reduce this irradiance, we will start to see a deviation. This deviation reaches 2 to 3% under 200 watt per meter squared. As we said earlier, we have also improved the temperature coefficient. So now the Tiger Neo 2 used to be at minus 0.29% per degree. And now the Tiger Neo 3 is minus 26% per degree C. Meaning that, for example, if we talk about 55 degrees C of cell temperature, we will find that the Tiger Neo 2 loses 8.7% of its power, while the Tiger Neo 3 only loses 7.8%. So this is observed constantly in operating condition because we are almost always above the 25 degrees cell temperature. So you will be expecting at all time at least 1% of production difference. We have also improved the warranty. The warranty, 30 years linear performance warranty. It used to be, the model used to lose 0.4% of its power every year. Today it's losing only minus 0.35%, meaning that by the year 30, we can see that the Tiger Neo 3 produces 88.85%, but the Tiger Neo 2 produces only 87.4% of its power. So if we combine all these points together, the temperature coefficient, the bifacial factor, and the low light performance, and annual degradation, and we compare Tiger Neo 3 to Tiger Neo 2, the previous generation, or the other TOPCon that is present in the market. We are not the only ones to produce TOPCon, but we think we're the best in it. So we expect 2 to 2.5% of improvement. And if we compare Tiger Neo 3 to the back contact technology, we expect 3 to 3.5 improvement. Now for our matrix, Tiger Neo 2 and Tiger Neo 3, we are proposing mainly 2 modules per category. We're talking about, let's start with Tiger Neo 2, we're probably familiar with, the standard size 66 HL4M. So it has a power class of 620 to 650, and it's the standard size. We have the larger model, the 66 HL5, also based on Tiger Neo 2 cell, and it has a power class of 720 to 740. Now with the upgraded version, the Tiger Neo 3, for the standard size, we have the 66QL6, Q standing for quarter cut cells. So we're talking about a power class of 650 to 670, which is at least a 20 watt improvement. And then for the larger module, we have the 66UL7 with a power class of 6 35 to 660, which is expected to start being commercialized by the end of this year. In our portfolio, we have also added new products that are for special applications. So they are based on the same cell. You will have the same electrical properties, the same performance, but with an adapted either glass or frame or coating for an application scenario. So, for example, we have the anti-glare module. Anti-glare module is used mainly in the airports and near the highways. They are modules that are 60% less reflective, so that it doesn't bother, the pilots driving the plane or the radars or people driving them on the highway. So it's 60% reflective with the same performance of the Tiger Neo 3. We have the triple advantage of the extreme weather product. This is a product where we have introduced thicker glass, and it has better mechanical properties. For example, it can resist up to 55 millimeters of hailstone, and it has a wind load of 6,000 and 4,000 Pascal, and also has a fire class A. For the offshore applications near the sea or floating PV or near the beach, so we have introduced the offshore module. This module, we have improved the anodization of the aluminum frame, and we have improved the IP rating of the connectors. So the connectors are now more resistant to salt spray and have a higher IP rating. And for the anti-dust and the desert module, we have introduced the desert module has a steel frame, so meaning more mechanical capacity, more capability to handle high wind loads, and also an anti-dust coating on top of the front glass that doesn't allow the accumulation of dust and organic debris. So as we said, the anti-dust is based on the same platform, Tiger Neo 3. You will find pretty much the same name, 66UL6 BDB, but with anti-dust or a steel frame added to it. Same power class. So the steel frame, as we said, it will has a better tensile resistance, 2 times better than standard product. It will handle higher loads. For example, for the front face load, standard product 5,400, but for the steel frame 7,000, and the rear side 2,400, and today 4,000. Also, steel frame has a better resistance to bending under high temperature. So we know that the aluminum sometimes bends a lot in high temperature, but the steel frame is at least 35% less bending than the aluminum. For the anti-dust coating, it has multiple properties. So it's, for example, hydrophobic. When water hits the surface, it automatically slides off without being accumulated on the module. And it takes all with it dust, dirt, and every other obstacle that can cause probably hotspots or production problems. For the offshore module, as we said, we improved the frame anodization. Used to be 10 micrometer frame anodization. Today is doubled, 20. And we added more sealant to have a better resistance to salt spray and to... Yes, please.
Please, I have a question. So when in your training, when you're discussing, you mentioned that you have improved your MC4 connectors.
Yes.
So resistance to salt waste.
Mm-hmm.
Please, what is the percentage resistance of the solar panel to salt waste, like ammonia or wind? For the solar panel.
For the solar panel or for the connector?
The solar panel.
The solar panel is resistant. There is a certification, salt mist IC 61 804, I guess. It's a certification where we take the module, we test it for salt spray, we put it in an environment with salt spray, multiple hours and multiple cycles, and then we measure if there is any discoloration, degradation, leakage of the salt. And if the model is okay without any degradation or without any effect, we will give the certification to this model. So all of our models are certified and we can supply the certification for it.
Thank you.
Thank you. But for the connector, I'm just going to this point now. For the connector for the offshore application, we will also supply an additional shrink tube that is installed on top of the module to make it even tighter and more resistant to salt spray. So that's pretty much it. If you have any questions, we can get back to the slides and explain further.
Both online and on-site.
Please feel free.
You can ask our students.
Also, another point we can see the fake models, how to verify the authenticity. So basically, let me just open.
So for the Tiger Neo 3, when is production going to commence?
Yes, okay.
Yeah, it has commenced. I think chipper that is coming in soon for you guys is 650 watts.
Okay.
Tiger Neo 3.1.
So the way we can verify, for example, if a module is authentic or not, we can just go to Google, like Jinko verification tool. We will find the official Jinko website, jinkosolar.eu, for example. We go right there. Okay, here we have a full explanation on how to verify this, all the steps, but let's go through them together. We click right here, confirm authenticity. Okay, now on each module, you will find a unique serial number, a unique barcode that you can either scan or write directly. So note that this number is unique. Each module have a different one. If you find modules that are duplicating the same number, that could be a sign. So we choose the country, for example, Nigeria, and then we put the serial number we find here. This is just a verification so that it prevents bots from spamming the platform. So you just put the number that you see here and you click verify. After clicking verify, you will find all the details of the module, power class, electrical properties, grades, everything. You'll find all the details, and you have to make sure that these details are identical to the details on the label of the module that you bought. Or sometimes you'll find a label that is faked. The product is okay, Jinko, but it's a different power class. So you check that everything is coherent and you have the good product. Any questions about this or the presentation or Tiger Neo 3? Any difficulties you're facing? Any questions you get from customers?
Or from sites.
Or from site, yeah. Yes, please.
Basically, in terms of generation, this Neo 3 for example, 670 model, what is the real power? That's it. That's what
The real power. The real power will depend on real life conditions. So usually how we evaluate this is we supply pan files and we have the software PPCs, which is a software that is recognized by almost globally, and it's even used and sometimes in contracts for utility scale. Sometimes a report from PVCs is enough to justify the performance. So we take the pan file, we load it into PVCs, we choose the exact site location, and it has a database of the meteorological database there that can simulate an entire year. And by the end of the simulation, you will get a full report of the losses of the production, even hourly, performance. You can see it because it depends on many factors. It depends on the sun position, depends on the weather, depends on. It's very unpredictable. So when we talk about rating, we talk about STC conditions. Since these conditions are unpredictable, we make very predictable conditions in the lab. 25 degrees ambient temperature and 1000 watt per meter square, and we rate the panel in those conditions.
Thank you.
Thank you.
Any further questions? You want to ask?
Yeah, I was going to further discuss on what the real power that he talked about. That's I'm sure he's trying to know, of course, for say a 670 watt Jinko panel, the client does not expect 100%, right? But at least depending on weather conditions, one is able to the intensity and all, at least one is able to pull up to below 75-80%. We've also gotten feedback from customers who say the panel is doing 90%.
In some condition, it can even reach 110 and 120%, especially if you consider the bifacial factor.
Yes.
Additional power from the back, and sometimes the condition in spring, something like this, the weather is the air is cold and the sun is shining. And these conditions are even better than the lab conditions, giving higher power than the rated power.
Yeah. But so far, we've gotten 90%. And that gives your customers confidence on the fact that it generates the efficiency is very high.
Yeah.
We also like to try it and give us some feedback. You buy the models.
Exactly. And there are also
yeah, I know. I'm talking about the 3.0. Yeah. So Janet will get the 650 watts soonest, and then you can also buy and then do your tests and get back to them. That information will reach us as well. Thank you.
There are tools also to test the performance of the module and how they work. You will find an IV tracer. This machine is, you connect the module into the IV tracer and you add, you also connect a reference that can measure the intensity of the light. And you connect also a PT100 to measure the temperature of the cell on the back of the module. And then what this machine will do, it will test the power that is given in real time and then take it back to the STC condition so you can compare it to what you see on the data sheet. Most of the times you will find higher power than expected because even our rated powers, 670 for example, it comes with positive power tolerance, meaning from 0 to plus 3%. Most of the time it will be higher.
But I'm actually interested in the anti-dust part of your presentation. Where you mentioned for specific regions, because we've experienced with solar panel cleaning in some areas are actually very challenging. So I don't know for The antidote doesn't come with Tiger Neo 2.0, right?
It's a special request.
It's a special request for that. But I think technology has to go to everyday mobile because of the certain conditions outside. Some localities where dust is
Exactly. We usually recommend this to be used not in everywhere, but in particular places where you have difficulties in terms of cleaning. We found yesterday a client that is cleaning every day the panels to keep them running. So this is also challenging, and you need to be considered. The additional cost of anti-dust can be justified and more than enough to
the cost is actually an
anti-dust.
issue.
Exactly, because it's not outside. If you make it a standard product, it becomes too expensive that the market will come once you get it.
If the operating cost is too high, a small additional cost to the panel is also very justifiable.
But for clients that want to compare the cost of cleaning every day, yes, and then to the extra cost of getting this model, if they look at it side by side, it's better to get the model than the cleaning every day. You know, look at So we will share the presentation slide with Genex Technologies. So we'll share the data sheet. And then we believe that, as time goes on, we will have more questions. You can as well share with us, and then we will respond to that. That's okay.
So just to conclude, the main points: better bifacial factor, meaning better power from the rear side of the module, which is additional power on top of what we already have. A less sensitive module to high temperature, meaning that it will perform better than the Tiger Neo 2 in high temperatures. Better warranty over the 30 years, and better low light conditions and anti-shading behavior. So these are the main points. Thank you.
All right, please let's.
So, yes. So, can you go back to the.
Yeah, sure.
We are going to.
All right, thank you so very much. Thank you so very much. It's been a very wonderful time having, especially our customers come around to experience this. Just like we have said, I'm sure in about 2 to 3 months we shall have the panels in stock here with us. And we'll actually be going live with it at Genex here. So just be on the lookout for those of us who are online and those who are here physically. So immediately after now, we'll take pictures. That's why we have the tab. We'll put all the tabs. So we'll take pictures.
You look like us.
Yes, all of us. Hey, so you already have the tab. So,
Manchester City.
yeah. I'm not a fan of Manchester City anyway, but I just have to.
For
Jinko.
Yes.
So I was telling her this morning that I see Jinko every day when I have to watch Man City and Barca and so, but fortunately we have to promote Man City and Jinko. She have been Chelsea.
They have decided to, partner with us to
As
go
well, yeah.
green. Yes.
Go green.
So tell Chelsea to partner with us to go green.
Can you imagine?
Of your club to partner with us
To go green. I see it's a very big deal that you guys are doing.
Yes.
Yeah. So, but before we take the pictures, let's appreciate Mr. Mohammed.
Yeah.
Let's appreciate him. Very much. Okay, so we'll wear our caps now and then take the picture. So we can just
It's one of those that came for the exhibition. Then I'm looking go
Alright, so master.
Okay, they came out go out next.
Yes. So when people come to the stand, they don't know if they should speak with them. Yes.
What you go out, always ask.
And I'm even.
Yes.
They are fixing it up.
I will first it. Yes, I'll just sign up.
That's something.
Yeah.
We move on to the just so.
Yes, if I'm new.
Let's call it.
No, yes. I'm not sure. Okay, small. Will I show?
That's my.
So can we also say Jinko?
Did you get that? No, we say it again.
Jinko. Can you do that?
Okay.
So can we say Jinko? Jinko. Jinko.
Thank you very much.
Thank you.
Thank you. Thank you, mommy.
Thank you, Mark. Thank you so much.
So please answer that.
Yeah. Joanna said she has sent it for the client to get back. Yeah, so the client will be quite on. I told her that you compare the price there, salary is 61. And if you then you can get the additional cost. But I'm not sure you guys have. Which of the 7? You have to contain.